Okay, so the last break was intentional. Well, not really intentional. It was really designed because I needed a break. And it was a good, hey, this isn't working. I need a break. Okay. I was on the right track here. Int number equals int malloc. Boom. I was on the right track. We need a pointer. We need to set the pointer variable to something, and it needs to be set in a loop. Okay. Explain why in a minute. And then we pass the number along. We got that. And then we're like, why isn't it working? I'm going to show you in a second. I put this one line in here and it works. So without that, right? It does work. Look, we don't actually need to free it, or we shouldn't need to free it. Okay. That was the thing that made it work. And you're like, wait a second, what? Let me double check. Yes. Okay. It's working. We did the thing. The free is not necessary. This freedom is not necessary. Okay. What we need to do is make this as fast as possible with the void arg here. Okay. So we're going to go ahead and get the argument. We're going to cast it as an integer and we're going to dereference it and we're going to store it in this number. Okay. We're going to try to do that as quickly as possible upon thread creation. We're going to try to do that as fast as possible in thread creation. Why? If I do it as fast as possible in thread creation, we never have an overload, right? Run it a few times. We never see duplication anymore. Why is that? Because you are, in fact, creating it for every iteration of the loop. That is, it's a different pointer. Okay? And you're like, wait, what? So it, the free thing makes it look like you need to have it, but and then I'm gonna put an arrow, and then I'm put D, and I'm gonna print a new line. Okay. So what I'm gonna print here is the arg. Yes, it's the pointer. And then I want to print the num that comes out of it. Okay. Um, let's try that again. Sorry. Those pointers should be different. And they're different because you created them in a loop. This is what's referred to as an automatic variable. I just didn't save it when I ran this. That's why it didn't work. Duh, right? So the free, why did I have the free there? Well, that frees up the memory and forces malloc to recreate it, but that's not necessary. And I kept thinking about it's not necessary, it's not necessary, it's not necessary, because it's not, right? It's not necessary. And so we can pass a number. And of course, we can do whatever we want with the number, right? So for instance, sorry, okay. Well, it's going to print a number of stars. Then there's a new line character. I'm sorry, there were chips next to me. Can't stop eating chips. Oh, didn't save it. Yes. Also, you know what I'm going to do? Let's get rid of this for a minute. Yes. We got three. You got two, you got zero, you got one, you got four. And you're like, wait, what? That's it. Okay. Now, a couple things. I'm going to actually bring all this back because I want to leave this. I believe I can toggle comment, right? Yes. Toggle line comments, bang. Bring this back, and I'm going to save it. Okay. We don't need to free it. In fact, I've done this a few times before, and I'm always confused as to why it does that, why it makes me free it, but we don't need to. I kept thinking about it, but this is the first time I come through it without having that. Okay. So now comes the big test. Big boy time. Okay. We're going to show status as well, but that's not what I mean by big boy. Okay. You guys might recall this song. It was when I was younger, so I don't think, right? Because you guys have not maybe been around as long as me. Okay. But what I'm going to do is I'm going to get the pointer to the argument. I'm going to print out the string and then I'm going to free it. Okay. Don't actually need to free it. So we're going to go ahead and kill that. But will the real Slim Sadie please stand up? Please stand up. Right. And now I'm making jokes. Yes. So what I'm going to do is create a new malloc 100 times. I'm going to string copy the thing from the array into that new FN. I'm going to create it and I'm going to pass FN. Okay. Boom. And then I'm going to join. And then I'm going to return the code. I want to return the code. You notice I'm returning a string length. So I'm returning the length of the string as my status. Should I be doing that? No. Status should generally not be that. Okay. Okay. And as you can see here, will the real Slim Sadie please stand up? It does, in fact, work. Is it in order? No. But you can see that the return code, we can actually return an integer. Now, you should not do this. This is bad mojo. Very, very bad. But here's how we can pass strings to it. Okay. But of utmost importance, and this cannot be overstated, cannot be overstated. You cannot and should not have a long running thing and using a variable. You should be creating automatic variables, a new pointer to point to each new thing. Okay. And the reason for that should be fairly obvious. If you don't, when you pass a pointer, two threads will have the same pointer variable and thus will actually do the same thing. And so you have to create a new thread in the loop. A lot of people do that wrong and it ends very, very badly. Okay, it ends very, very badly. You'll note also I do a string copy to take the and put it in there. Because what I was doing before was looping through, but as you do that, you change the string array. And so it's usually not considered a good idea. Okay. All right, so that is two of our jobs. The next job we're going to do is try to show you how unsafe this is. Now, a lot of you are going to go, oh, Dr. Ruth, are you really going to do that withdrawal thing? Yes. Why wouldn't I do the withdrawal thing? We're kidding, right? No, I'm not kidding. We're doing the withdrawal thing. So let's keep our code simple, right? And then we need a function, right? And what's our function name? Void withdraw, and it takes an int amount. Boop, right? Now, should we write it like a function? We could. I'm not. I'm going to have my threaded function called a non-threaded function. Why? Because I can. Yes, and you're like, wait, what? Because I can. Okay. So void withdraw int amounts. If amount is greater than balance, right? And you're like, wait, what? We're gonna have a global variable. We're gonna set it to be I don't know, $1,000, whatever you want to set it to. I believe it'll be okay. Amount is greater than balance. We're gonna take the balance. We're gonna return the amount. So I already screwed this up. Else, we're gonna return zero. We're gonna do anything to balance, we're gonna return zero. Yes? Boom. Okay. Yeah. No kidding. Oh yeah, there we go. Duh. There we go. So now they're congruent. Okay. I'm just gonna quick compile just to make sure we're happy with what we got so far. It is compiling, so we're good. Okay. So what I'm gonna do now is kind of dumb. Okay. So what I'm gonna do is like our P thread 4, maybe. We created 4 of them, right? We're gonna go ahead here and we're gonna do what we did in P thread 4. Okay. Not very exciting. We're just gonna create 3 threads. Okay. And each thread is gonna withdraw $100. And that's all it's gonna do. Okay. It's not gonna do anything with the arguments. We're not gonna pass arguments to it. It's just gonna withdraw $100. Yes. So at the end here, we're gonna go ahead and start off by identifying what the initial balance is. Yes? Oops. Come on, Michael. You can do better than that. There we go. I'm aware, full out aware that this is going to do nothing. Okay. This is not going to, should be $700, by the way, right? Should be $700. Yes. Okay. We're going to do more magic here later on, but this is what we're going to do in our thread. Okay. Balance is 1,000. It creates the 3 threads. It waits on the 3 threads. Yes. Let's make sure that we're actually subtracting the balance. Yes. Come on, Ruth. Screwing around. Something weird is happening here. So let's see what it is. Yes. So we're just going to do it in a couple places. Ha, now I know what's wrong. The amount is bigger than the balance. The balance needs to be bigger than the amount. I just put the things wrong. It never actually changed it. It just kept returning 0. So the amount needs to be less than the balance. Yay! So we don't need this actually. Um, it is in fact working. It was just duh, Michael. Um, right. So the balance should be $700. It is $700, and we know it's working. Okay. So let's do something silly. Int threads equals 3. Okay. Now, instead of creating that, I'm going to go ahead and replace you. And I'm going to replace you. And I'm going to replace you. Yes. Now I'm going to print F and I'm just going to do the same thing, but I'm going to actually print it. I'm going to fix it. Fix it. Right? So instead of saying should be, I'm going to go D and I'm going to remember what the original balance is. Okay. Right. So we have the original minus threads times 100. However many threads it is, right? Do do do. So let's see if that is going to be accurate. We got some sort of error somewhere. Let's go ahead and compile it and see where the error is. I don't see the error, so let's see it. How is it a variable size object? Let's do it this way. That's wrong. Is it def? There we go. And I only want three. I don't want 1,000. Yes. And it's happy now. Yes. Why does it say invalid? Yeah, it's not invalid. Okay. So now we got it working. Yes? Great. So now let's get rid of this hard-coded one and let's mess around. Right? Right. So we know it's going to work if it's three. What about if it's 3,000? Okay. Couple things are going to happen pretty quickly. Uh, our balance is, I'm sorry, hold on. Our balance is 1,000 originally, right? As you can see, and we're taking out 100. So we can only do this 10 times before we run into immediate problems. So whatever. So it's not going to really be very realistic anyway, because once it gets past 10, it doesn't matter. But will it create 1,000 threads? Sure will. And the balance should be 299,000, right? Why is that? 3,000 threads times 100 results in $300,000. And then you're subtracting it away from 1,000. Yes? So, but let's actually make this more realistic, right? We can't check to see if it's a correct value. Yes? Because it shows that the balance is 100, by the way. Yes? And that is because it never withdraws um, the last amount. And you go, wait, what do you mean? So you see this amount less than, right? We should make this less than or equal. Pretty simple. All right. It never withdraws that last amount. Okay. So saved it. Let's run it. Run it again. Sorry. As you can see, it takes a minute to run, right? Should be negative 200,000. Okay. And it's zero. And you go, wait, what do you mean? It's 100,000 and we should be pulling 2,000 out of it, right? Right. Original threads is 3,000 times 100. Original should be 100,000, right? Unless I'm doing this wrong, my scrolling's not working really well. Yeah, it's 100,000. So it should be negative 200,000. It's never going to go negative, right? So remember, it's never going to go negative. So let's add two more zeros to this. And we should actually get a positive number here. Remember, you need a positive number what this should be. Yes, otherwise you can't worry about it matching. And yay, it matches. Great. Now let's make it 30,000 threads. But before we do that, because my life is not perfect, let's go ahead and remove the after and before, and let's just go to town. Okay. And you go, wait a second. Okay. Should be 700,000. Bang, it is. What about 300,000 threads? Okay. We're still 10 million. So we should still have a positive number, right? Yes. I press play and it's still waiting. Oops. Did it die? Ooh, it crashed. Did it? Yep, it crashed. Way too many threads. Okay, 300,000 threads. Once it gets past a certain number, it can't do it. And note that we're not allowed to create some. I'm going to do it again, and it should kill again. Um, well, there you go. But we get a number that's not the right number, and you go, how is that even possible? Okay, it's actually quite simple. It tried to create a bunch of threads. The system prevented the threads from creating, so those threads were never actually running, but the code still runs because the main thread was still running. Yes? You add more zeros, right? And you're like, okay, okay, why is it not the right number? I told you. It's not actually allowing you to create the threads. It's just not happening. This isn't a thread safe problem. It's another problem. Now, I'm not sure we solved this problem today, but I do want to show you a real safe problem. Okay. Using the same bit of code, exact same bit of code. Okay. Okay. We have the withdraw amount, this, but instead of one time, what we're going to do instead, oh, come on, Ruth, we'll go with 10,000 times, right? We're not going to withdraw $100. We're going to withdraw $1. Okay. We're not going to create 1,000 threads. We're going to create 5. Okay. Now, 10,000 times 5, 50,000, right? Do we need 100? No, we don't. Okay. We can have that money and it'd be fine. Okay. This isn't going to work anymore, right? Should be threads times 1,000, right? Because that's how much it's going to be withdrawn. Okay. You're going to have a problem here. I might not have enough here. Okay. But this is where the problem is going to occur. This is the thread safe actual, oops, excuse me. This is where a thread safe problem might actually occur. And sure enough, a whole bunch of those rights were overwritten and you get an incorrect balance. And you go, wait a second, but it's only 5 threads. How can it do this with only 5 threads? Oh my God. So it's not a problem with creating too many threads. In fact, that's not even doesn't even come close to the problem. The problem is that you have a massive number of small rights, and that means overlapping here is the problem. In our next class, we're going to show you how to fix both problems to some extent. But we need to do locking in order to fix them. So obviously, we're going to fix this problem first, P9C problem first, and then worry about P8 problem later. Okay. How do we deal with the max number of threads? We'll deal with that problem later, but first we have to deal with the this problem as well. In the process of doing that, we'll also, in the process of fixing the race condition, that's what this is happening here. We're also going to look at some deadlock situations and how do we kind of deal with them. Although we're not going to really try to do prevention as much as, hey, how do we avoid this entirely? And we will talk about the conditions for deadlock as well. And then finally, we'll wrap up by talking about how do we fix max number of threads, right? How do we deal with the max number of threads? How do we actually, so P8 is as much a problem as P9. As we can see, look, how many people see the error here? Does anybody see an error here? There's no error, okay? There's no error. And nothing here indicates an error of any sort. And you're going, wait a minute, what? It doesn't. You just get an incorrect result. That is the same incorrect result as you get with this. This is too many threads, and the threads are just dying secretly, and nobody knows what the hell is going on. So we'll deal with the max number of thread problem as well as the race condition problem next class. Make sure that you have any questions, make sure you ask them. Y'all have a great day. Try to remember how to stop the recording.